Hello everyone, welcome back to the channel. Today, we are exploring in unprecedented depth the massive overhaul of its Garibaldi and its groundbreaking transformation to operate the Bayraktar TB3 drones. This is not a simple maintenance task or minor upgrade, it is a complete reimagining of naval operational capability, integrating unmanned aerial systems with traditional warship platforms to redefine multi-domain maritime strategy. Its Garibaldi, originally commissioned in the early 1990s as a helicopter carrier and amphibious assault ship for the Italian Navy, has entered a new era of operational capacity with the integration of Bayraktar TB3 drones. These unmanned aerial vehicles provide the ship with enhanced intelligence, surveillance, reconnaissance, and precision strike capabilities, extending its operational reach far beyond traditional limits. The history of its Garibaldi is rich, beginning in the late 1980s when the ship was laid down to provide Italy with a versatile amphibious assault and helicopter deployment capability. Commissioned in the early 1990s, the ship quickly became a mainstay in Italy's naval fleet, participating in humanitarian missions, multinational exercises, and strategic deployments. Over decades, incremental upgrades were applied, radar and sensor enhancements, modernized propulsion systems, and updated defensive and offensive armaments. Nevertheless, the current overhaul is by far the most transformative, integrating cutting-edge UAV technology directly into the ship's operational framework. Central to this modernization is the Bayraktar TB3 drone, which features vertical takeoff and landing VTOL capability, advanced autonomous navigation, modular payloads, and precision strike potential. This UAV's design allows seamless operations from Garibaldi's retrofitted flight deck, enabling unmanned missions to operate alongside helicopters and crewed aircraft without compromising operational efficiency. The TB3 extends the ship's reconnaissance range, increases real-time battlefield intelligence, and enables precision engagement in contested maritime zones. The deck and hangar modifications were extensive and required meticulous naval engineering. Flight decks were redesigned to create dedicated zones for drone launch and recovery, incorporating automated handling systems to facilitate rapid deployment and retrieval of multiple UAVs. Hangar spaces were upgraded with maintenance bays, charging stations, and secure storage for TB3 drones, ensuring operational readiness even during extended missions. Advanced command and control centers now allow operators to manage multiple UAVs simultaneously, integrating them fully into the ship's sensor and communication networks. Bayraktar TB3 drones offer unmatched operational flexibility. Their VTOL capability allows them to operate in confined maritime environments, while modular payloads enable adaptation to diverse mission profiles, surveillance, electronic warfare, target designation, and precision strikes. Data from ship-based sensors are fed directly to the drones, allowing autonomous operation based on real-time intelligence, while drones relay high-fidelity data back to the Garibaldi's Operations Center for rapid analysis and decision-making. This creates a continuous feedback loop, enhancing situational awareness and operational responsiveness. Operationally, Garibaldi's transformation expands its role from a traditional amphibious assault and helicopter carrier to a fully networked, multi-domain maritime force. With the integration of TB3 UAVs, the ship can conduct extended surveillance over vast maritime areas, support precision strike operations, and coordinate with allied forces in joint exercises. The integration also significantly enhances interoperability, demonstrating Italy's commitment to leading in unmanned naval operations. Strategically, the upgrade places Garibaldi at the forefront of naval innovation. By combining manned and unmanned capabilities, the ship becomes a versatile command platform capable of real-time decision-making and rapid force projection. It represents a forward-looking approach to naval warfare, prioritizing information dominance, flexibility, and the ability to conduct complex missions with reduced personnel risk. The technical specifications of the upgraded Garibaldi remain impressive. Retaining its original propulsion system, the ship maintains high-speed maneuverability and long-range operational capacity suitable for Mediterranean, European, and global theaters. Flight deck enhancements allow for concurrent operations of helicopters and multiple TB3 drones. Defensive systems have been modernized, including advanced missile defense, electronic countermeasures, and integrated combat management systems. Maintenance and logistics for UAV operations are optimized through automated systems and modular payloads, reducing manpower requirements while increasing operational readiness. The human factor is central to this modernization. Crew members undergo specialized training in drone operation, sensor data analysis, and multi-platform coordination. This training ensures that unmanned systems are effectively integrated with traditional ship operations, enhancing mission performance. Operational doctrines have been updated to reflect the integration of autonomous systems and networked operational strategies, ensuring that the Garibaldi can respond dynamically to emerging threats. Globally, the Garibaldi's modernization reflects a trend towards unmanned system integration in naval forces. UAVs are increasingly seen as essential tools for expanding surveillance, reconnaissance, and precision strike capabilities while minimizing risk to personnel. The Garibaldi serves as a prime example of how legacy platforms can be transformed to meet modern operational requirements, providing a blueprint for other navies seeking to combine manned and unmanned systems. The Bayraktar TB3's capabilities are central to this operational leap. Its autonomous flight, precision navigation, and modular payloads enable it to perform a wide range of missions, from long-duration surveillance to precision strikes. When operating from the Garibaldi, the UAVs significantly extend the ship's operational reach, providing persistent intelligence, rapid target acquisition, and precision engagement capabilities. These drones operate seamlessly with the ship's systems, forming a networked force capable of executing strategic objectives efficiently. Integration of UAVs required comprehensive technological upgrades. Advanced mission planning software enables simultaneous operation of multiple drones, while secure communication links protect sensitive operational data. Sensor fusion technology links the ship's radar, sonar, and electronic warfare systems directly with the drones, creating a real-time operational picture that enhances situational awareness, decision-making, and rapid response capability. Naval engineering challenges were significant. Weight distribution, deck load capacity, and center of gravity considerations were meticulously recalculated to maintain stability and maneuverability. The flight deck now supports automated drone launch and recovery, while hangars provide secure storage and maintenance capabilities. Safety systems, firefighting protocols, and emergency procedures were enhanced to accommodate increased UAV operations and high-tempo mission cycles. The modernization also has symbolic and strategic significance, reflecting Italy's commitment to next-generation naval warfare. The Garibaldi demonstrates how legacy platforms can evolve to meet emerging threats, integrating advanced technology with human expertise to maintain operational superiority. The ship serves as a living R&D platform, providing critical insights for future naval design, UAV development, and operational doctrine formulation. Environmental considerations were incorporated to minimize ecological impact during drone operations, maintenance, and power usage, reflecting a growing commitment to sustainable defense practices. Human-machine collaboration is a cornerstone of the Garibaldi's effectiveness. Crew members are trained to coordinate with autonomous drones, interpret sensor data, and execute complex multi-domain missions. This teamwork between humans and machines enhances operational performance, providing capabilities that neither could achieve alone. Operational exercises have validated these systems, demonstrating successful deployment, recovery, sensor integration, and real-time data transmission. Strategically, the Garibaldi now provides Italy with extended maritime domain awareness, rapid response capability, and enhanced force projection. The combination of manned and unmanned systems allows for simultaneous operations, improving operational flexibility and effectiveness. Garibaldi can operate independently or as part of larger task forces, providing intelligence, surveillance, and precision engagement in contested environments. The ship is also future-proof, capable of integrating next-generation UAVs and mission systems as technology evolves. From a geopolitical perspective, the Garibaldi TB3 combination signals Italy's commitment to cutting-edge maritime capability. This modernization enhances Italy's operational readiness, strategic influence, and regional security posture. It may inspire allied navies to pursue similar integrations, promoting interoperability and coordinated unmanned operations in multinational contexts. International collaboration played a crucial role. Partnerships with defense contractors, technology providers, and allied navies facilitated UAV integration, ensuring interoperability, safety, and operational efficiency. These collaborations enabled knowledge sharing, best practices, and technological innovation, resulting in a highly capable, modernized platform. In conclusion, the ITS Garibaldi is over. Continuing seamlessly from Part 1, the ITS Garibaldi's transformation into a UAV-capable platform with Bayraktar TB3 integration further exemplifies Italy's commitment to next-generation naval operations. Beyond the physical and structural upgrades, the ship's systems have been meticulously integrated to ensure that every mission, whether surveillance, reconnaissance, or precision strike, is executed with optimal efficiency. The operational workflow on board Garibaldi now revolves around the synergistic interaction between manned systems, automated processes, and unmanned aerial vehicles. Launching a TB3 drone begins with pre-flight checks conducted by both the automated maintenance systems and crew operators. The drone's flight paths are coordinated with helicopters and other aircraft operating on the deck, ensuring seamless multi-aircraft operations. Once airborne, each drone maintains a continuous data link with the operations center, streaming high-resolution imagery, sensor readings, and telemetry directly to the ship's command hub. Sensor fusion technology is critical in this ecosystem. The data from the ship's radar, sonar, and electronic warfare systems is dynamically combined with information gathered by TB3 drones, creating an integrated, real-time operational picture. This unified situational awareness allows commanders to make informed decisions rapidly, whether tracking potential threats, coordinating strikes, or managing fleet movements. The continuous feedback loop between UAVs and the ship ensures that information is always up to date, providing a decisive edge in maritime operations. Maintenance and logistics have also been reimagined. Automated systems handle routine inspections, recharging, and payload swaps for the drones, drastically reducing turnaround time between missions. Hangar spaces now feature modular maintenance bays with robotic assistance, allowing multiple drones to be serviced simultaneously. The operational readiness of the UAV fleet is continuously monitored through smart software systems, ensuring that Garibaldi can deploy a full complement of drones at any time without delay. Crew roles have evolved alongside technology. Operators receive specialized training in UAV management, data analysis, and integrated mission planning. Their responsibilities include supervising automated systems, interpreting sensor data from multiple sources, and making strategic decisions in real time. The human element remains vital, ensuring that even with advanced autonomous systems, missions are executed according to strategic objectives and operational doctrines. The TB3 drone's modular design allows rapid reconfiguration for diverse mission types. For surveillance missions, drones can be equipped with high-resolution optical and infrared cameras, providing persistent coverage over contested maritime zones. In electronic warfare or intelligence operations, payloads can include signal interceptors and jamming systems. For precision strike roles, drones carry lightweight guided munitions capable of neutralizing threats with minimal collateral damage. This flexibility makes Garibaldi a multi-role, multi-domain operational hub. Strategically, the Garibaldi TB3 integration enhances Italy's maritime domain awareness, operational flexibility, and rapid response capability. The ship can independently conduct surveillance, intelligence gathering, and precision strikes while maintaining interoperability with Allied forces during joint operations. The combination of manned and unmanned assets allows simultaneous execution of multiple missions, significantly increasing operational tempo and effectiveness. Internationally, the Garibaldi serves as a benchmark for naval modernization. Its ability to integrate legacy platforms with advanced UAV technology demonstrates how traditional ships can evolve to meet contemporary operational challenges. By showcasing operational proficiency and technological innovation, Italy reinforces its position as a leader in naval strategy, encouraging allied nations to adopt similar multi-domain, networked approaches to maritime security. Future upgrades are already being considered, including next-generation UAVs, enhanced payloads, improved AI-driven autonomous mission planning, and expanded interoperability with allied platforms. These enhancements will ensure that Garibaldi remains at the forefront of naval capability for decades, adapting to emerging threats and maintaining strategic relevance in complex maritime environments. Continuing directly from the first two parts, this third installment explores the operational doctrines, tactical employment, logistical endurance, and the human factors that make the ITS Garibaldi paired with Bayraktar TB3 drones a formidable and adaptable maritime force. The following narrative keeps the flow seamless, building on previous descriptions of deck modifications, sensor fusion, automated maintenance, and crew training to examine how such a platform operates over extended deployments, how commanders plan and execute missions in contested environments, and how the system scales when integrated into multinational task groups. Operational doctrine aboard Garibaldi has shifted from a platform-centric model to a mission-centric approach where the ship's assets are allocated dynamically in response to evolving intelligence and operational priorities. Instead of pre-assigned roles for helicopters, small craft, and embarked troops, mission planners now allocate aerial assets both manned and unmanned as modular packages tailored to mission phases. A single sortie may include a manned helicopter for search and rescue, a TB3 for persistent surveillance and electronic sensing, and a smaller unmanned surface or subsurface vehicle providing local environmental data. This modular orchestration demands robust mission planning tools, real-time communications resilience, and a culture of operational adaptability among the crew and command staff. Mission planning has therefore become a multidisciplinary activity combining intelligence analysts, electronic warfare specialists, aviation operators, and naval commanders. Pre-mission briefs synthesize satellite imagery, human intelligence, signals intelligence, and predictive analytics to create flexible flight plans for TB3 drones. These plans include contingency branches. If a drone identifies a target of interest, it can autonomously switch to a loiter and identify mode, stream high-definition imagery to the operations center, and await human authorization for escalation to a kinetic option. This human-on-the-loop model balances the advantages of autonomy with the ethical and legal responsibilities that arise with armed unmanned systems operating near civilian maritime traffic and contested coastal zones. Commanders also depend heavily on the ship's secure data links and hardened communication nodes to maintain persistent control and situational awareness. Redundant satellite communications, line-of-sight relay buoys, and encrypted mesh networks allow TB3 drones to operate beyond visual line of sight while remaining within the ship's operational envelope. In hostile environments where adversaries may attempt to jam or spoof signals, TB3s switch to pre-programmed fail-safe behaviors, autonomously return to a pre-designated rally point, loiter in a protected corridor, or execute a controlled landing on a recovery pad. These behaviors are continuously refined through software updates and lessons learned from exercises and real-world operations. Sustained operations at sea pose unique logistical challenges. Power management, for example, is a critical concern when multiple drones are charging simultaneously while the ship is also powering radars, electronic warfare suites, and propulsion systems. Smart power grids on board Garibaldi prioritize critical systems and distribute charging cycles to avoid detrimental power peaks. Energy storage technologies, including high-capacity battery banks and next-generation capacitor arrays, were integrated into the ship's refurbishment to ensure that UAV sortie rates remain high without compromising other mission-critical systems. Hybrid power management software continuously monitors consumption and can forecast peak demand windows, allowing mission planners to stagger UAV launches to maintain operational tempo. Spare parts management for TB3s and their payloads employs predictive maintenance algorithms. Sensors embedded in drones monitor component health in real time, recording vibration signatures, battery degradation curves, actuator performance, and wear indicators in landing gear. This telemetry flows back to the ship's maintenance systems, which use machine learning to predict failure modes and prompt preemptive replacements. The result is a reduction in unexpected downtime, increased sortie rate, and more efficient logistics chains. Supply manifests are therefore dynamically updated and integrated with regional supply nodes. When Garibaldi operates with allied task groups, it can request parts replenishment from nearby carriers or amphibious ships with compatible logistic capabilities. Human factors remain central amid these technological advancements. The psychological and cognitive demands on drone operators and analysts are significant. They must monitor multiple video feeds, assess sensor anomalies, make rapid judgments about potential targets, and coordinate with strike assets under constant time pressure. To mitigate operator fatigue and improve decision accuracy, the Garibaldi employs human-centered interface designs, including alert prioritization, context-sensitive data overlays, and assisted target recognition tools that highlight objects of interest for rapid human review. Rotational watch schedules, resilience training, and crew welfare programs are embedded in deployment plans to maintain high levels of alertness and morale during protracted missions. Interoperability with allied forces is a force multiplier for Garibaldi's capabilities. NATO standard data formats and common operating pictures enable TB3 collected intelligence to be immediately useful to coalition partners. During multinational exercises, TB3s have been tasked to provide overwatch for amphibious landings, coordinate time-sensitive targeting information with naval gunfire support, and act as forward sensor platforms for anti-submarine warfare ASW tasking. In ASW scenarios, TB3s fly above potential submarine transit lanes, deploying sonobuoy aerial drops or relaying acoustic sensor information gathered by unmanned surface vehicles back to Garibaldi's ASW center. The integration of airborne unmanned sensing with surface and subsurface unmanned platforms creates layered detection capabilities that complicate adversary concealment efforts. The TB3's utility in maritime interdiction and law enforcement operations is also noteworthy. For non-kinetic missions such as counter-piracy, fisheries protection, and search and rescue, TB3s provide persistent surveillance at lower operational cost than manned aircraft, while their sensor packages can perform automatic vessel identification and flag status checks. In humanitarian operations, drones can rapidly assess coastal damage, identify survivors, and deliver small life support packages via precision drops, enhancing the speed and effectiveness of maritime humanitarian responses. Training pipelines for Garibaldi's crew emphasize cross-domain skills. Aviators learn basics of unmanned systems and networked operations, operators are trained in maritime law, rules of engagement, and shipboard seamanship to better understand the operational environment. Maintenance teams receive advanced robotics and systems diagnostics instruction. Cross-training ensures flexibility. A small core team can sustain UAV operations during high operational tempo while other crew members manage core ship functions. Such cross-domain literacy is essential for a modern navy that leverages both human and machine capabilities. Tactically, commanders experiment with mixed formations of manned and unmanned aircraft. A helicopter may carry an extended lift platform while TB3s perform overwatch, enabling vertical replenishment or troop insertion under the protective observation of UAV-based sensors and electronic defenders. In contested airspace, TB3s can feed precise targeting data to surface-to-air missile SAM batteries or to embarked anti-ship missile systems, reducing the sensor-to-shooter timeline and increasing the probability of intercept. The capability to disperse sensors across a wide area increases resilience against concentrated attacks. Losing one UAV does not blind the task group. Rules of engagement and legal considerations for armed drone operations at sea have been carefully codified. Italian naval lawyers and operational commanders work to define thresholds for escalation, requirements for positive identification, collateral risk assessments, and protocols for civilian vessel proximity. Part of this legal framework includes mandatory human-in-the-loop confirmation for any kinetic engagement originating from TB3 payloads. The emphasis on legal compliance and proportionality serves both strategic and political purposes, maintaining legitimacy in operations and reducing the risk of unintended escalation in politically sensitive maritime environments. In contested electromagnetic environments, the Garibaldi relies on a blend of active and passive defenses. TB3s equipped with electronic surveillance payloads can identify hostile jamming sources, map signal densities, and help the ship reconfigure its own emission control (EMCON) posture. Drones can act as decoys or as distributed electronic attack platforms, degrading an adversary's targeting capability while preserving the task group's operational freedom. When integrated into a layered defense plan, TB3s extend the reach of electronic warfare beyond the horizon, complicating enemy situational awareness and command and control. Another operational dimension involves counter-UAS measures. As adversaries also adopt unmanned systems, Garibaldi's defensive suite must detect, identify, and neutralize hostile drones. Integration of TB3 collected data with shipborne radar and optical systems improves small target detection. Countermeasures may include directed energy systems, kinetic interceptors, or electronic jamming designed to subdue hostile UAVs without escalating to wider conflict. The ship's doctrine emphasizes graduated responses, prioritizing non-destructive defeat options in areas with civilian maritime traffic. Strategic messaging is also a factor. The visible presence of a drone-equipped Garibaldi during routine patrols or exercises communicates technological sophistication and resolve to both allies and potential adversaries. It acts as a deterrent by demonstrating integrated intelligence and rapid reaction capability. Diplomatic considerations guide deployment patterns. public diplomacy and clear communication with regional partners help reduce misperception and avoid accidental confrontations. Research and development activities revolve around iterative improvements. Software-defined payloads allow TB3s to download new sensor modules or countermeasure algorithms while at sea. Experimental payloads such as microsynthetic aperture radars, coastal mapping LiDAR, and lightweight anti-ship loitering munitions are evaluated on board. Data from these experimental missions feed back into procurement cycles, accelerating the deployment of effective technologies. The ship's role as a testbed shortens the gap between prototype testing and operational deployment, enabling faster adoption of successful innovations. Long-term sustainment strategies factor into procurement choices. Survivability improvements, modular upgrades, and commonality of components reduce life cycle costs. When possible, open architecture systems were selected to encourage third-party development and to avoid vendor lock-in, allowing Italy to incorporate allies' innovations and to adapt to unforeseen technological shifts. Investment in simulation and digital twin technologies for Garibaldi helps planners rehearse missions, predict maintenance needs, and assess the impact of upgrades without disrupting operational availability. Finally, the human narrative of the Garibaldi's crew is essential. The ship's sailors take pride in operating at the cutting edge of naval capability, embracing a culture that blends traditional seamanship with high-tech systems operation. Their stories of long watches on deck as drones ascend at dawn, of tense moments when target recognition decisions are made in seconds, and of the camaraderie that develops as diverse specialists work together convey a richer picture of modern naval life. That human element, resilience, adaptability, and expertise is what ultimately transforms technology into operational power.